Welcome back to Scholar Strive doing some math. Today we're working in Algebra II, properties of exponents, and a little bit of scientific notation. So here we go. Our first property, product of powers. If we have powers being multiplied together of the same base, we just add them together. So for example, we have 5 to the third times 5 to the fourth. That means we can just add the exponents together to get 5 to the seventh. Now this only works when we have the same base. So our base here is 5. If there were different bases, then we cannot use this property. Our second example here, x to the 13 times x to the negative fifth. So that would be x to the 13 plus a negative 5, which becomes x to the eighth. Alright, second property, power of a power. Raise a power to another power, multiply exponents. So here we have a base to a power, and then to another power. That's when we multiply the exponents together. So for the first example, we have negative 3 squared to the fifth power. So we take we take that squared and then multiply it to the fifth. So that's 2 times 5, so that's negative 3 to the 10th power. And then in the next example, y to the 6th to the second, that's y to the 6 times 2, so that's y to the 12. Our next property is power of a product. So when we have two numbers being multiplied, and then they're both being raised to the same power. So, for example, we have 3a quantity squared. Not only are we squaring the 3, but we're squaring the a as well. So it becomes 3 squared a squared, or 9a squared. Same deal here, x squared times y to the third power. So that's the x squared is going to the third power, and then that y is also going to the third power. So we have x to the 2 times 3 from our previous property there, and then y to the third equals x to the 6, y to the third. So when we have a negative exponent, so here our property says a to the negative m, all we do is flip it over to the denominator and make our exponent positive. If our negative exponent is in the denominator, we can flip it up to the numerator, as long as a isn't 0. Because 0 in the denominator means undefined, we're not allowed to do that. So for example, we have 3 to the negative 3 right here. And then, since we have a negative exponent, we can move it to the denominator and make the exponent positive. So we have 1 over 3 to the third. And 3 to the third is 3 times 3, which is 9, times 3 is 27. So we have 1 over 27. And then in the next example, we have 1 in the denominator. We can move it to the numerator. So this is actually 5 to the x squared. So our next property is the zero exponent property. And this one's easy. Anything to the 0th power is 1. In class, I kind of show you the reasoning why everything to the 0th power is 1. But here, if we have negative 2x to the 0th power, anything to the 0th power is 1. So that's what our two examples show. Next up, quotient of powers. So if we're dividing exponents of the same base, we just subtract the numerator from the denominator. So, for example, we have 6 to the negative third over 6 to the negative fifth. So now we have 6 to the negative third minus negative fifth. So 2 minuses make it plus. So negative 3 plus 5 is 2. For our next example, we have y to negative 10 over y squared. This is y negative 10 minus 2, which is y to negative 12. We don't like having negative exponents, so we're going to flip over 1 over y to the 12. Power of a quotient. So this is when we have some sort of fraction, and they're both being raised to a power. Same thing when we're multiplying two things, we just raise them to the power separately. So 3 to the 5th to the 4th is the same thing as 3 to the 4th over 5 to the 4th. X to the y to the negative power is x to the negative second, y to the negative second. And then we don't like having negative exponents, so we just flip them over and make the exponent positive. So y to the negative second was the denominator, now it goes to the numerator. X goes back to the denominator. Alright, let's move on to scientific notation. So, I'm just going to do a quick review on scientific notation, because you should have seen this in your earlier classes, or science class, some sort of science class. But here we go. What we're doing is changing either super big numbers or super small numbers into something that looks neater, easy to write, and easy to calculate with. So we have a big number here, 805 million. To change that into scientific notation, I'm going to go to the decimal point here, which is all the way at the end, and I'm going to count how many times it gets to me to that 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So I'm going to say that this is equal to 8.05 times 10 to the 8th power. Because remember, when we're multiplying by 10, we're just moving zeros. So 805 million, you can check in your calculator, is equal to 8.05 times 10 to the 8th power. Part B, we got a super small number, 0.000053. All we're going to do is move the decimal point forward until it's in front of the 5. So 1, 2, 3, 4, 5. So that is 5.3 times 10 to the negative 5. So remember, it's negative if we're making a small number, positive if we're making a really big number. Write each number in standard form. So part C, they were already given scientific notation, now we just need to write it in standard form. Standard form is just the number written all the way out. So we're going to start off with 6.2. Oh, let me fix that, please. There we go. So I'm just going to move my decimal place 6 times to the left. So 1, 2, add a 0 here, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6, 2. So this number here and that number here are the same thing. And then part D, we're doing positive numbers, so we're going to go to the right because we're making the number larger. So we have 3.102. So I'm going to go 1, 2, 3, 4. Add a 0. So this is 31,020. Alright, that is scientific notation, frontwards and backwards. Alright, let's move on to some stuff that you're going to see on the homework. Here we go, let's do some example problems. Number 1, 4 to the negative 7 over 4 to the negative 3. They're the same base, so when we're dividing exponents, all we're going to do is subtract them. So this is 4 to the negative 7 minus 3. So those two minus makes a plus, so negative 7 plus 3 is 4 to the negative 4. Since we don't like having negative exponents, this is going to become 1 over 4 to the 4, which is the same thing as 1 over 4 squared. 4 squared is 16. 16 times 16 is 256. Okay. Number 2, we have 3 squared s cubed to the 6th power. So remember, this is just being distributed to here and here, and we're going to multiply. So this is 3 to the 2 times 6, s to the 3 times 6. So this is 3 to the 12th, s to the 18th. 3 to the 12th power, punch that into the calculator, and I think it is 531,441. And then s to the 18th power. So that's an s at the end there. So once again, that's 531,441 s to the 18th. So this number 3, distributing again. 4 to the 0 times negative 5 is still 4 to the 0, so that becomes 1. Anything to the 0th power is 1. And then we have w to the 2 times negative 5. So that becomes w to the negative 10. We don't like negative exponents, so this is 1 over w to the 10th power. Alright, number 4. So, we're multiplying these together. So all we have to do, if we're multiplying base or exponents with the same base, all we do is add them together. So this is y to the 4 plus a negative 3, and z to the 2 plus a negative 5. So 4 minus 3 is 1, so y to the first, z to the negative 3. So we have y on top, z to the third on the bottom, because we don't like negative exponents. Alright, number 5. So this negative 2 is getting distributed to this, to c, and to the 7th. Okay? So let's think of it as 7 to the first. So 7 to the first times negative 2 is 7 to the negative second. So let me write it out here. 7 to the negative second. 7 times negative 2 is negative 14. And d to the second becomes d to the negative 4. Okay? So all these are negative, so everything's going to go in the denominator. So I'm going to have 1 over 7 squared, which is 49, c to the 14th, d to the 4th. And that's it. Next. Okay, so when we're dividing, we can only divide things of the same, same type. Q's to Q's, R to R's, numbers to numbers. So 16 divided by 4, well, that's 4. So 4 goes on top. Let's just have this, just in case. Q to the 0 minus q to the 3 is q plus 3. So we have q to the 0 minus negative 3. And then we have r to the negative 6 minus 7, minus 7. So in this case, we're not going to have anything in the denominator. So this is going to be 4 q to the positive 3, because minus makes positive. And then negative 6 plus 7 is r to the first. Whoops. Let's head back. There we go. So our answer is r q to the third, or 4q to the third r. All right. Next up, number 7. Let's see. So 8 over 18, if we just look at that as a fraction, that can be reduced. So I can divide both of them by 2 and get 4 over 9. So at the beginning, we have 4 at the bottom, or top, 9 on the bottom. So e to the negative 4 minus e to the first is e to the negative 5. F to the negative second minus, wait, is that a negative 5 there? Okay, I'm going to assume that is f to the negative second minus negative 5. So I'm going to clean this up again a little bit. So I have 4. E is going to go down and become positive exponent. And then negative 2 plus 5 is f to the third power. Okay. Number 8. X to the fifth divided by x to the fifth. Well, anything divided by itself cancels or becomes 1. So y to the negative 8 minus 6 is y to the negative second. We don't like negative, so we're going to flip it over and make the exponent positive. Number 9. 5 to the 0 times 5 to the first times 5 to the negative 7th. When we're just multiplying these together, we just add all the exponents together. So 0 plus 1 plus a negative 7. So that would be 5 to the negative 6. And then we don't like that, so that's going to be over 1 to the 5 to the 6th, which becomes 1 over some huge number, 15,625. 25. Alright, let's move on. Okay. So this one, there's a lot going on in number 10. You just do it one step at a time. So here we go. So the first fraction, c to the fourth to the third. So remember, we're not adding, we're multiplying those exponents. So this is c to the 12th. And then we have 4 down here. Now we're going to look at the next fraction. 12 over 15. Oh, wait. Parentheses first. So on the denominator there, you can see me circling that. 15cd is to the negative first exponent. So what happens is, that's just going to be flipped over to the numerator and then to the first power. So what's going to happen is I have that 12d to the negative 6. And then here comes that 15, so times 15cd. Okay. So 12 times 15 is going to be... Actually, let me put... So nothing's in the denominator here. So since everything's being multiplied, I'm just going to connect this. So everything is getting multiplied up here up top. Everything down there is getting multiplied. So we have 12 times 15 divided by 4. If I put that in my calculator, I'll get 45. So 45. So that's 12 times this 15 divided by 4. So 45 here. And then we have c to the 12th times c to the 1st. So that is c to the 13th. Okay. And then we have d to the negative 6, which is d times d to the first, that becomes d minus 6 plus 1, so that becomes d to the negative fifth. And then the d negative fifth becomes d to the positive fifth because we move it down. All right. Next up, number 11. X to the... So everything in here is getting distributed. So that goes to the top, the numerator and the denominator. Okay. So I'm going to rewrite it. So since it's to the exponent, we're just going to multiply everything. X to the negative 14, y to the positive 4, 3 to the negative second, and then y to the positive 6. And then I'm just going to move everything that's negative to the opposite side. And so I have 3 to the second power up top becomes 9. And then we have x to the 14 on the bottom. And then we're going to look at y to the 4th minus y to the 6th. And that's going to be y to the negative 2nd. So finally, we have 9 over x to the 14th, y to the 2nd. Next up, number 12. So this is b to the 9th to the negative 1th to the negative 2nd. So all we're doing is b times, or 9 times negative 1 times negative 2. So 9 times negative 1 is negative 9. Negative 9 times negative 2 is positive 18. So this is b to the 18. And that's that. 13. Alright. So 2 times 5 is 10. M to the 5th plus, or m to the 5th times m to the 3rd is m to the 5 plus 3. So this is 10 m to the 8th. Next up, so if we have two fractions being multiplied together, I'm just going to combine that. So now instead of being, so everything is being multiplied here. And now we'll notice that we have v to the negative 5 up top, v to the negative 5 on the bottom. That means we can cancel. So remember, we can only do this if we're multiplying everything on the top and bottom. So those cancel. I'm left with w negative 3 over... Whoa, what's going on? W to the 3rd. So w to the negative 3 minus 3 is equal to w to the negative 6. We don't like that, so 1 over w to the 6. 15. Okay. So q by itself. So q, not gonna happen. Nothing's not gonna happen to q. Same with the 5. So 5q. R squared times r to the cubed is r to the 2 plus 3. And then we have s to the 6 plus a negative 3. So this is 5q, r to the 5th, s to the 3rd. That's an s. S. Okay. 16. Working with some scientific numbers, but everything's being all multiplied together, so it's okay. So what I'm going to do is I'm just going to take 1.2 and 6.7. So remember, there's not a plus or minus sign here. I am not foiling. Everything's being multiplied together, so I'm just going to multiply my numbers together, my 1.2 and 6.7. And I'm going to get, calculator, 8.04. Okay. So times 10 to the negative third plus a negative 7. So this is 8.04 times 10 to the negative 10. And this is about the only time we actually keep negative exponents, is when we're representing something in scientific notation. It's to represent, it's like, hey, this is a really small number, probably dealing with some molecules or whatnot. Number 17. So 1.1 times 10 to the negative third over 5.5 times 10 to the negative 8. So because there's no plus or minus here, I can actually do 1.1 divided by 5.5. 1.1 divided by 5.5 is very similar to 11 over 55. That becomes 0.2 or 1 over 5. So we have 0.2 times, so we look at our 10th powers here, we have 10 to the negative 3 over 10 to the negative 8. That means that's 10 to the negative 3 minus negative 8. So the two minuses make positive. Negative 3 plus 8 is 5. Alright, one more problem and then I'll let you guys go. The radius of Jupiter is about 11 times greater than the radius of the Earth. How many times as great as Earth's volume is Jupiter's volume? Okay, so they're saying the R of Jupiter is equal to 11 times the radius of Earth. Jupiter's big. How many times as great as Earth's volume is Jupiter's volume? Now, this is a while back, but volume of our sphere here is equal to 4/3 pi r cubed. Okay, so when we're going to compare Jupiter Earth, okay, so we're going to have V over Jupiter over V over the Earth. So that's going to equal 4/3 pi r cubed. Okay. Now we don't need to look up the radius of actual Jupiter or Earth for this one. They're just telling us it's 11 times greater. So for Earth, we have 4/3. Oh, sorry. Jupiter. Sorry. So here comes 4/3 pi r cubed again. Okay. Remember that the radius of Jupiter is actually 11 times bigger. So I'm going to put 11 in here. And that represents my radius there. And then there is our Earth. Okay. So I'm just going to eliminate. Since everything's being multiplied, I can cancel our 4/3 out, our pi's out. Okay. Now, what I can't do right away is get rid of the r cubes. But here we go. 11 to the third power is 1,331. And then we have r cubed there over r cubed. Those cancel. So we're left with 1,331 times larger than Earth's volume. Jupiter's big. Alright, don't forget to do your worksheet. Have a good day.